Welcome to my VTube and Facebook channel. Today my topic very important from a reaction mechanism. We have discussed different reaction mechanisms. Today I will teach you one mechanism, that is electrophilic addition reaction. Two terms, electrophilic and second term is addition. Why electrophilic? Electrophilic reactions, those reactions in which the first attacking reagent on the substrate, on the molecule is electrophile. When the first attacking reagent is electrophile, we call those reactions electrophilic. Then addition reactions, what happens in those reactions? An unsaturated compound is converted into a saturated compounds. So I have written here, addition of a reagent or a simple molecule across carbon-carbon double bond in alkenes or in alkynes to convert an unsaturated compound into a saturated compound. So that is we call addition reaction. Now in these reactions they are initiated by electrophile. That is, the first attacking reagent is electrophile. And third point, in these reactions, carbocations are involved as reactive intermediates. So in these reactions, the intermediate formed is carbocation. So this is what we call addition. Unsaturated compound changes into saturated compound, but the first attacking reagent is electrophile, or we can say these reactions are initiated by electrophiles and the carbocations are involved as intermediates. We will discuss this topic with the help of some examples. A known example is addition of halogen acids like HCl, HBr, HI. These are called halogen acids. Addition of halogen acids to alkenes. To form alkyl halides. This is a well-known example of electrophilic addition. For example, carbon-carbon double bond. This is called ethene. Plus HCl, hydrochloric acid. Now hydrochloric acid has two parts. This is H, delta positive charge, chlorine, delta negative charge. It has one electrophilic part and other is nucleophilic part. What we have to remember, what we have to learn is, this H will go to one carbon. It will attach itself to one carbon in alkene and other carbon will get chlorine. So double bond will be broken into single bond. We'll get this thing H. This will get H. Then H and H and Cl. chloroethane. So we get chloroethane, alkyl halide, or simply called ethyl chloride. Simple reaction, one carbon will get H from the addendum from HCl, and other carbon will get chlorine or halogen to form an alkyl halide. This is the simple reaction. Now we will learn its mechanism of electrophilic addition. We will see how carbocations are involved as intermediates in this reaction. Let us learn mechanism of electrophilic addition. Step first. In step first, electrophilic part, I mean H positive, attacks on pi bond. Electrophilic attack on pi bond to form carbocation. So in the first step we will get a carbocation. Carbocation like this, carbon carbon double bond, this is ethene plus HCl, electrophilic part, and this is nucleophilic part. In first step, this H positive, it is electrophilic part, it will attach itself to one of the carbon atoms and will form a covalent bond with one carbon like this. Electrophilic attack on pi bond. So the first thing we will get is H, H and H, then H. Now this carbon will get a positive charge. This is called 1 degree carbocation. So this is the step first. This carbon completes its valency, it forms 4 covalent bonds, and this carbon is left with only 3 covalent bonds. So it becomes a carbocation. Now in second step, nucleophilic part, that is Cl negative, halide ion, it will attack this positively charged center. Since electrophile attacks first, H positive, that is why we call them electrophilic addition reactions. This is the step first. Electrophilic attack on pi bond to form carbocation. Now we will write step second. Step second. Cl negative ion attacks positively charged carbon halide ion will be attracted towards the positively charged carbon to form addition product, to form an addition product like this. Now this Cl negative, it will be attracted towards positively charged carbon. It will act as nucleophile and form a covalent bond with this. We'll get CH3, CH2, Cl, chloroethane. This is called the addition product. The reactant was unsaturated and the product is saturated. I hope the mechanism part is clear. Okay, good. If our alkene is unsymmetrical, if the alkene to which electrophilic addition takes place is unsymmetrical, so I will write, in case of unsymmetrical alkenes, if the alkene is unsymmetrical, electrophilic addition that takes place according to Markovnikov's rule takes place according to Markovnikov, Russian chemist. Markovnikov's rule. What is that rule? I will write a simple statement of Markovnikov's rule. It is statement MR. MR stands for Markovnikov's rule. It states that electrophile goes to that carbon. Electrophile attacks. It attaches itself to that carbon in alkene. Goes to that carbon in alkene which has more number of hydrogen atoms. That carbon which has already more number of hydrogen atoms. Why so? What is the reason for this? In order to form a more stable carbocation. In order to form a more stable carbocation, because the yield of the product, stability of the product depends upon the stability of carbocation. If carbocation is more stable, product formed is also more stable. So in Markovnikov's rule, electrophile attaches itself to that carbon of alkene which has already maximum number of hydrogen atoms in order to form that carbocation which is more stable. Because when the carbocation is stable, product formed is also more stable. I will explain this Markovnikov's rule with a suitable example. CH3 CH double bond CH2. It is called propene. You can see its structure. This terminal carbon has 2 hydrogen atoms and middle carbon has only 1 hydrogen. It is called propene. We will add HCl to it or HBr. HBr, hydrogen bromide. Now this reaction has two pathways like this. Path number first and path number second. This H is electrophile and this Br is nucleophilic part. So path number first is MR. MR stands for Markovnikov's rule. And second alternative is AMR. Anti-Markovnikov's rule. Opposite to that of Markovnikov's rule. Let us write the option first. This is H. It will go to that carbon which has more hydrogens. Remember, this has two hydrogens and this has one hydrogen. So according to Markovnikov rule, this H positive will go to terminal carbon. So we will get CH3, CH, CH3. It was initially CH2, it became a CH3. Now this carbon attains positive charge. It becomes a carbocation, but 2-degree carbocation, more stable. 2-degree carbocation, more stable. And opposite to the Markovnikov rule, we have one more option. That's AMR. Let us suppose this H goes to middle carbon. That is called AMR. CH2, double bond is broken. Now this terminal carbon acquires positive charge. It becomes 1-degree carbocation. It is less stable. Now, in the end, halide ion will come, bromide ion. That has also two options. That will attack this central carbon and will give one type of alkyl halide and will also go to terminal carbon and will give a different alkyl halides. So, in these reactions, we will get two products. One product will be major in quantity, in yield, and other will be minor. Now, which one will be major? Whose carbocation is more stable? Now, you can see, now will come bromide. Here also, bromide. We will get CH3, CH, here Br, CH3. It is called 2-bromopropane. It will be major product, major alkyl halide. Its yield will be greater in high quantity because its carbocation is more stable. In this case, we will get CH3, CH2, then CH2, Br. 1-bromopropane, but it will be a minor product. It will be a minor product. It will be less in yield because its carbocation is less stable. Thank you very much for watching this video. For more useful and interesting videos, do subscribe to my channel and press the icon button.